This is the second part of May-June 2020 paper 1-1, and we're going to be continuing from question number 15. So here it's universal set x is such that x is an integer and x is less than equal to 10 and greater than equal to 1. So these contain then f is x is such that x is a factor of 24. So here 1, 2, 3, 4, 6, 8, all are factors of 24. And x is such that x is a square number. So when we take their square root, we get a whole number, which is 1. 4 as 4, square root of 4 is 2, and 9. So now we need to complete the Venn diagram. So in F and S, we have 1 common and 4 common. So 1 and 4 would go here. Then in F, we have 2, 3, 6, and 8. And in S, we have 9. The rest left will come outside, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then we have to find the number of F union S intersection complement. So F union S, which means both of these. So what we need is not this. What we need is the complement of this. So here we have 5, 7, and 10 because they don't come in this. So 5, 7, and 10. So the total number is 3. So the number is 3. In the Venn diagram, shade the region represented by P intersection Q intersection R complement. So let's first shade P intersection Q. So this is P and this is Q. So this is P intersection Q. Next we need R complement. So for R complement, yes, let's use this. R complement is everything except R. So now we need its intersection with this. So for that, we need the overlapping region, which is just this. So you just need to shade this region. Question 16. Solve the equation 5 minus 2x is equal to 12. We'll keep minus 2x here. We'll take 5 there. 7 divided by minus 2. So 7 divided by minus 2 is the same as minus 7 divided by 2, which gives us minus 4.5. Part B is find the integers that satisfy this inequality. So when we have something like this, we'll take this as 1 and then this as another 1. So this over here, we'll have x, we'll take 3 over there. So x is greater than equal to minus 5 over 3. Minus, you can calculate minus 5 over 3. Right. So approximately minus 1.66. So x is greater than minus 1.66, and over here x is 3 will divide over here. So x is less than 2. So it says to find the integers that satisfy. So we need to find all the integers that are greater than minus 1.66 and less than equal to 2. So here we'll have minus 1, 0, 1, and 2. Next we have a function f of x is equals to 5 minus 4x. We need to find f of 3. So here 3 is in the position of x, so we will replace x with 3, minus 3, sorry. So minus 4 into minus 3 is positive 12, and we'll get 17. Next we have to find the inverse, f inverse of x. For that, our step 1 is to write f of x as y. Then we need to make x the subject. So I don't like having minus 4 in the denominator, so I'll take minus common. So as here it's positive, it's going to be negative. As here it's negative, it's going to be positive. So over here, x is sorry, I made a mistake here. We're just, as I've taken it common, it's this is gonna, wait, I'm gonna take a negative common from the numerator, and then this will cancel out with this. So x is 5 minus y over 4. And now I'm gonna replace the y with x and x with y. And this is my f inverse of x. The quadrilateral PQRS is drawn on a 1 centimeter square grid. Write down the name of this special quadrilateral. So if it has two bases and a height, it's a trapezium. Find the coordinates of the midpoint of QR. So Q here is, its x coordinate is -2, its y coordinate is -3, Q and R. Its x coordinate is -5 and its y coordinate is 2. So the formula of midpoints is x1 plus x2 over 2, y1 plus y2 over 2. So let's give this x1, y1, this x2, y2. So -2 plus -5 divided by 2, and -3 plus 2 divided by 2. Here -2 -5 -7 over 2, and -3 plus 2 is -1 over 2. So our answer is -7 over 2 and -1 over 2. The length PS is equals to the square root of m centimeter. Find the value of m. So the formula for length is for x2 minus x1 whole square plus y2 minus y1 whole square. So let's go and see what x1, x2 and y1, y2 are. So P, the x coordinate is 4 and the y coordinate is 3, and for S, the x coordinate is -2 and the y coordinate is 5. So this is our x1, y1, x2, y2. So x2 is 4 minus and x1 is -2, and y2 is 5, and wait, x2 was 4, so we'll take y2 as 3 and y1 as 5. Four minus 2 is 6, so 6 squared is 36, plus 3 minus 5 is -2, and -2 squared is 4, which gives us 40. So our m would be 40, as it is also with the square root. Next we have matrices. P minus 3Q. So P minus 3Q. So here first I will multiply 3 with Q, but just 3, not the minus. So 3 zeros are 0, 3 minus 1 is minus 3, 3 into 5, 15, and 3 into 4, 12. Next step would be to subtract these. So 4 minus 0, this will be subtracted from this will be subtracted from this with this, and this with this. So 4 minus 0, minus 2, minus 3, minus 1, minus 15, and 3 minus 12. So here 4 minus 0 is 4, minus 2 minus 3 will be minus 2 plus 3, which will give us 1. Minus 1 minus 15 is minus 16, and 3 minus 12 will give us minus 9. So this is our answer. The next is the determinant of R is 11, find D. So to find the determinant, we need the product of this diagonal subtracted by the product of this diagonal. So 4 into 2 minus 1 into t is 11. So 8 minus t is 11. Minus t, sorry, minus t is 11 minus 8. Minus t is equals to 3. The minus will go there, so minus 3. Find R inverse. Now to find R inverse, what we need to do is we need to change the position of these two and put a negative sign with these two. And it will be overall divided by the determinant. So 2, 4, their position is changed, and 1 will become minus 1 and minus 3 will become 3. And it will be divided by 11. Y is inversely proportional to the square root of x. So here we have y is inversely proportional to the square root of x. This can be written as y is equals to k over the square root of x, where k is a constant. So we need to find the value of c and d. So first let's find the value of k. Over here we have these. So when y is 3, x is 4. So from here we'll get k as 6. Now we need to find the value of c. So for c, we have y is c, k is 6, and x is 9. So c is equals to 6 over the under root of 9 is 3. So c is 2. Next, let's find d. Here, our y is 0.6, our k is 6, and we need to find d. So we'll take this over there, and we need to move this decimal point forward, so we'll multiply it by 10 and we'll multiply this by 10. So 60 divided by 6, which will give us 10. And because it's a square root here, we'll take its square and then we'll take its square. So we'll get 100. The diagram shows the position of two ships A and B drawn to a scale of 2 centimeter to 1 kilometer. So first, I need to measure the bearing of B from A. So I don't have protractor with me here. I can't use it here, but what you need to do is measure the bearing of B from A. You need to move it clockwise from A to B here. So you need to put your protractor here and measure this angle. You should get 128. The next is find the distance between the two ships A and B in kilometers. So you will put your scale here, and then you will measure this length from A to B. You will get 7 centimeters, but you need it in kilometers. So 2 centimeter to 1 kilometer. So here you have 2 centimeter to 1 kilometer. You have 7 centimeter to x kilometer. So you can cross multiply this and you will get 3.5 kilometers. Now I can't do this part as well, but I will tell you how it's done. Equidistance from A and B, which means you need to draw a perpendicular bisector. So to do that, what you need to do is put your compass here and draw a line here, and then put your compass here and draw a line here. And then you're going to put your compass here and draw a line here, and put your compass here and draw a line here. And then you need to pass a line that passes through the middle of the intersection of both of these. The next part is on a bearing of 260 from B. So B, you're going to extend this. From here to here you get 180. You need 260. So you're going to subtract 260 from 180, and whatever angle you get, you're going to measure it from here. And wherever you get the line, you're going to mark that line to that point. So if you get an angle drawn here, or maybe here, then you're going to mark the point here. One solution of the equation sine m is equals to 0.3 is m is equals to 141. Find the solution when m is less than 90 and greater than 0. So we know that sine is positive over here and over here. So it's already positive here. So to find it in the next quadrant, all we need to do is subtract 141 from 180, and you're gonna get 39. Okay, the formula for the nth term of a sequence is 2n squared. Find the third term of the sequence. So this n is the number of terms. So all you need to do is put 3 here. So 3's power 3 is 27, and then you're gonna get 54. Here are the first 4 terms of another sequence. Write down the next term of the sequence. Now here you can see a pattern. Here it's the square of 2, then 3, then 4, then 5. So the next term would be the square of 6. So, and here in the denominator you have 3, 5, 7, 9. So it's increasing by 2. So it's an arithmetic sequence. So after 9 you're going to get 11, which is 36 over 11. So find a formula for the nth term of the sequence. So for the denominator, it's pretty simple as it's an arithmetic sequence, and we know for arithmetic sequence we have this formula. So over here our first term is 3 and our difference is 2. So this is for your denominator. Now for your numerator, we know that it's the square of something. So for the first term, it was the square of 2. For the second term, it was the square of 3. So for the number of term plus 1 square, because for term 1, it was the square of 2. For term 2, it was the square of 3. For term 3, it was the square of 4. So it's always n plus 1 whole square. So this is your answer. Okay, the diagram shows a cone and a cylinder. The cone has a radius 28 and a slant height y centimeter. The cylinder has a radius 15 centimeter and a height 42 centimeter. The curved surface area of the cone and the cylinder are equal. So for the cone, this is your curved surface area, and for the cylinder, its formula is 2 pi r h. You need to memorize this. So pi rl is equals to 2 pi rh. So for the cone, we'll have pi, r is 28, and l is y. And for the cylinder, 2 pi, r is 15, and h is 42. So pi will cancel out with pi, and y will be 2 into 15 into 42 divided by 28. Let's just cut this. 2 ones are 2, 2 ones are 2, 2 fours are 8, 2 sevens are 14, 2 twos are 4, 2 ones are 2, 7 ones are 7, 7 threes are 21. So in the end, we'll get 15 into 3, and we're going to get 45. OP and Q are points as shown in the diagram. OP is equals to A minus 2B and OQ is equals to 4A plus 4B. Express PQ as simply as possible. So in terms of position vectors, PQ is going to be OQ minus OP. And OQ is 4A plus 4B. And OP is A minus 2B. So 4A plus 4B minus A minus minus plus plus 2B. So 4A minus A plus 4B plus 2B. So 4A minus A is 3A and 4B plus 2B is 6B. So this is our answer, 3A plus 6B. Write as a single fraction in its simplest form. So first we're going to take the LCM, which is x plus 4, 3x minus 2. Then we're going to multiply this with this and this with this. And we're going to simplify it. 2x into 3x, 6x squared. 2x into minus 2, minus 4x. 3 into 3x plus 9x. 3 into minus 2, minus 6. Minus 5 into x, minus 5x. Minus 5 into 4, minus 20. So over here, these are the like terms. So minus 4 plus 9 gives us positive 5, and positive 5 minus 5 gives us 0. So these can be cut out. So we have 6x squared minus 6 minus 20 will give us minus 26, and x plus 4, 3x minus 2. So this is our final answer. And this was the whole paper.